Hi, I'm Miss Hall, and this is Lesson 90, Describing Normal Distribution, Skew, Center, Spread, Outliers. Recognizing normal distributions. Not all distributions are normal. For instance, consider the histogram shown below. The first histogram has a normal distribution. Notice that it is bell-shaped and symmetric. Recall that a distribution is symmetric when you can draw a vertical line that divides the histogram into two parts that are mirror images. Some distributions are skewed. The second histogram is skewed left. So if we were to draw a curve over the second histogram, we call it skewed left, which was hard for me to understand because it builds and the highest part is at the right. So I have to remember that it all depends on where the tail is. I call this the tail of the distribution. I'm going to say this is the tail, so it's skewed left because that's where the tail is. And the third histogram is skewed right. Again, so I consider this part the tail of the histogram, of the distribution curve, of the curve I'm trying to set over the histogram to see any patterns in the data, and it is on the right, so that's why this is skewed right. The second and third histograms do not have normal distribution. So none of the rules we learned before with the empirical rule with the 60, 895, 99.7, those do not apply to a skewed left or a skewed right histogram. Okay, both skewed left and skewed right, they do not have normal distribution. And something interesting to note is that of a normal distribution data set, the mean and the median are equal. And when you skew left, the mean, the average number, is less than the median, the middle number. And that reverses for skewed right. The mean in a skewed right is greater than the median, the middle number. Example 4, recognizing normal distributions. Determine whether each histogram has a normal distribution. A, the heights of women in the U.S. ages 20 to 29. I'm going to put a curve over the histogram. And this is roughly bell-shaped. It is bell-shaped enough that we are going to consider this normal distribution. Yes, this histogram approximates normal distribution. And now if we do the same thing to B, I'm going to put a curve over the histogram that models the histogram. That is not a bell-shaped curve. This is a skewed data set, and it matters where the tail is, which I consider this the tail. I do not think that's official term, so don't use that anywhere else. Tail is right, so no, this data set, this is not normal distribution. This distribution is skewed right. And again, on the first one, on A, we can then start applying our 68% of the data lie within one standard deviation of the mean. We can apply and we can calculate z-scores like we've done in previous lessons. And with the skewed distribution B, we can't use any of those formulas. Those formulas only apply to data that has normal distribution.